Now let's take a look at Newtonian mechanics, founded by this guy, Sir Isaac Newton. Now, Isaac Newton had a little in common with Batman, but we'll get to that later, and feel free to ask in class. First thing we're going to talk about is a reference frame. So when we're looking at forces do work when we exert them over a distance that changes energy. You always need to know which way is up. So first thing you want to do in any problem, just as you've always done, set up axes, so you know which way you're going. And you can also assume positive and negatives based upon your axes. As long as you're consistent, you're going to be okay. It's also worth noting that all of Newton's laws only work for inertial reference frames, which is a frame that's not accelerating. Now, very important, it can be moving because all it means is that delta V equals 0. So as long as it's moving at a constant velocity, you're going to be okay. Now, my favorite demo. Okay, wait. Watch. I put a block on a table. What'd it do? Absolutely nothing. This is my favorite demo because it's never failed yet. Newton's first law just says that an object's velocity remains constant until an external force acts on it. This word external is very, very important. It also sets up law of inertia, where inertia is a resistance to changes in acceleration, or F equals ma. I like to think of inertia as an object's tendency to keep on keeping on. Oh yeah, back to this word external. If we're looking at this word external, that explains why when your car breaks down and you're on this rainy road, you have to get out of the car to push because you need to be external. External forces can accelerate systems. Now on to Newton's second law. Newton described everything in terms of momentum, which is given the symbol P. Who knows why? I don't. But it is defined as the quantity of mass times velocity. I like to think of it as oomph. So a net force causes a change in an object's momentum. Oh, look. So if we assume that this could happen two ways. You could either change its mass, or you could change its velocity. We're going to assume that your mass is going to stay the same in this class, so we're only going to focus on dv dt, which is in fact acceleration. So force net equals mass times acceleration. It's the product of mass times acceleration. I view it in terms of acceleration as F net, so this force causes this mass to accelerate. Now, force diagrams. We've done a little bit of this in class, but let's take a moment, pause the video, draw on your sheet of paper. What are the forces acting on here? Okay. First case, so if you're ready to go, we'll go. You've got normal force pushing up and gravity pulling down. This case, gravity always pulls straight down, but the normal force, remember normal force is perpendicular to a surface. So it is a 90 degrees from the surface. And here, this is a ball just being thrown through the air. So gravity acting straight down, the force of gravity. And we're just going to assume that it's thrown through the air. We're going to say it's going right. So we're going to call this friction, air resistance, drag, assuming this ball is going straight to the right. So forces acting on an object. Notice velocity and acceleration aren't on here because they're not forces. Moving on to a couple examples with Newton's second law. You have two people pushing this box. We want to know what is the force person A exerts. Well, this is the net force, so that's the sum of all forces, and this is the acceleration in the x direction. Notice we're talking about forces in the x direction and accelerations in the x direction. So we split it up. Person A and person B are both pushing on this box. We set this up as... I'll move that over to this side. The arrow's a little misleading there, I'm sorry. So, the acceleration of a 50 kilogram box, because both of these people are external to that box at 2 meters per second, minus negative 500. Notice this negative sign, if I set up positive to the right, negative just means to the left, and I get it is 600 newtons. This is positive, so the person A is pushing with 600 newtons to the right. Example 3. Now we're going to find the acceleration due to gravity of an object on the Earth's surface. We're going to start by relating this to F net, Newton's second law, and then we remember that we define forces as the change in potential energy. So here I have my change in potential energy. Oh, here's that mass of the object accelerating. Oh, look, there's an m of the object on both terms. That cancels out. You plug in your numbers, you can look them up for the mass of the Earth and r squared, and you get the acceleration of this object is 9.8 meters per second, where this negative just means toward the center. All right, the negative just means towards the center of the Earth, because I assumed away from the center is positive. Because if I move away from the center, I am increasing my gravitational potential energy. I hope that helps, and please ask any questions you have in class. I will talk to you then. Thanks.